Example 8. Figure 2.6 shows a relation between P and Q. Write this relation in set builder form and roster form. What is the domain and range? Okay. So now what do you see? 9 is linked to 3 and minus 3. So 9 is linked to 3 and minus 3. 4 is linked to 2 and minus 2. So 4 is linked to 2 minus 2 and 25 is linked to 5 and minus 5. So 25 is linked to 5 and minus 5. This one is not linked to anything. Also, you have to notice that. Okay. So, in that, the set builder formula, relation is going to be set of all ordered pairs x, comma, y such that x in the rend dot another, this is called such that x belongs to, this symbol is called belongs to P, comma, y belongs to Q. Is this correct? Okay. Now, what else are we writing? X belongs to P and Y belongs to Q. And what do you notice here? 9 is the square of 3 and minus 3. 4 is the square of 2 comma minus 2. 25 is the square of 5 comma minus 5. Correct? So how do I write this relation? X comma y such that x belongs to P and y belongs to Q. And what is the relation between x and y? I see that x is the square of y. Or how else can you write this? Or y is the square root of x. You have two ways of writing. Square root of x. You have two ways of writing this. So this is your set builder form. Write any one of these. Or you can write this. Okay. So you have two ways of writing this. This is the set builder form. So this is my first subsection. Now roster form kekranga. What is my roster form? It is going to be the general way of writing the ordered pairs. So the relation is going to be x comma y. X has to belong to P and y has to belong to Q. Correct? So I'll write 9 comma 3, 9 comma minus 3. Correct? 9 is related to 3 and minus 3. It is linked to 3 and minus 3. You see the arrow mark here? 3 and minus 3 over here. Okay? So I have 9 comma 3, 9 comma minus 3, 4 comma 2, 4 comma minus 2. Then I have 25 comma 5, 25 comma minus 5. So this is my roster form. Okay? Now they are asking for domain and range. So if domain it is going to be all permissible values of the relation in the x coordinate. So domain is going to be 9, 4 and 25 without any repetition. Okay? So this is going to be 9, 4 and 25. Range is going to be all permissible values that are in the relation which are in the y coordinate. So it is going to be 3 minus 3, 2 minus 2, 5 minus 5. So it is going to be 3 minus 3, 2 minus 2, 5 and minus 5. Just neat you can also write this in the proper order. So you can write minus 5, minus 3, minus 2, 2, 3, 5. Okay, properly writing it in the ascending order. Okay, now codomain. They have not asked for the codomain, but what is our codomain? It is going to be, we are only going to focus on the output. Correct? So output I have 5, 3, 2, 1, minus 2, minus 3, minus 5. Okay, so you have to write everything that is in the output. So that is going to be our codomain. So you will have 3 minus 3, 2 minus 2, 5 minus 5 and you have minus 1 or 1 now. You have 1. Okay. So that is one value which is not used at all, but that is also included in your codomain because codomain will include all your output values. Okay, you don't have to consider your input when you're talking about codomain. Okay, clear? Now, example 9. Okay, there is a note. The total number of relations that can be defined from set A to B. A to B, the number of relations is going to be the possible subsets of A cross B. Okay, we just learned what the number of subsets of A cross B is. So you have number of elements in A to be P, number of elements in B to be Q, number of elements in A cross B is going to be the product of these two. So the number of subsets is going to be 2 to the power PQ. Correct? So this is what we learned in our previous examples and exercise questions when we are learning about Cartesian products. So so they have given the total number of relations is going to be the number of subsets. N cross B is this. The total number of relation is going to be the total number of subsets. Okay. So now you have N of A is, I have 2 elements. So N of A is 2. What is my N of B? That is also 2. 2. So I have 2 elements. So the number of elements in A cross B is going to be number of elements in A multiplied by number of elements in B, which is going to be 2 times 2, which is going to be 4. So the number of subsets of A cross B equals 2 to the power of number of elements in A cross B. So which is going to be 2 to the power 4. So this is 2 to the power 4 and 2 into 2 into 2 into 2, 4 4s are 16. So I have 16 relations. 16 relations. Okay, please copy.